Hi, my name is Vladislav Belogrudov. I'll try to answer a very simple question. Docker is quite popular nowadays, and we try to manage quite complex systems and software with Docker. And the question is whether Docker is fit for OpenStack and how easy it's to deploy with Docker. And maybe this is a kind of silver bullet for OpenStack deployment. So some background and disclaimer. I'm Oracle employee and I also contributor to OpenStack Kolla project. And this is my own opinion, so don't blame anyone but me. Docker is a quite popular thing. It's really revolutionized how we build software, how we distribute it, how we install. And it's really tries to help us to manage complexity with divide and conquer. Think, that in Docker world you can put complete service into a container, and you can abstract from underlying deployment platform, more or less. And users should be also should have more time for other things, but instead of configuring zillions of RPMs or Debian packages to install OpenStack. Some benefits I'll try to cover here. Docker images or Docker containers, they are very easy to build with help of Docker files. So instructions to build Docker files and Docker images are quite easy. You just say what you want, run Docker build. And you can also use latest and the greatest software in Docker images, so it's not necessary to wait for RPMs from whatever vendor and or for packages from PyPy archives. So you just use instruction like git clone in your Docker file, and you will get latest, greatest Nova, Cinder, and other services. Nice thing about Docker is that batteries are included. You don't deal with zillions of RPMs and dependencies as a deployer, so you just get full sync, nothing needed. And it's very easy to upgrade. So when you have running container, you want to replace it with new one, you just stop container, pull new image, and start new container. That's easy. So here come some pitfalls and problems I'll try to cover. A few of them. In old school or hosted solutions, when you have RPMs or packages and don't use Docker, for example, you have some service with packages A, B, C, and you try to upgrade package A, for example, RPM, some library, right? You do update of this package, and only this package is actually updated. And in Docker world, when you, for example, try the same thing, you try to replace package A with newer version. Full rebuild is necessary, and you get really new Docker image with all the other stuff built anew, and it should be pulled as a new container by deployer. So you would also ask me, what about layers? Docker is kind of onion structure where you have a very easy thing. In Docker files, you specify instructions, and each instruction is saved as a layer in the image. So you do X, it's stored in layer 1. You do Y, it's stored on top of layer 1 as layer 2, and so on. So this is true, but there is a problem with that too. Same layers in multiple images, they're never easy, and actually it's almost unrealistic case. I'll tell you why. And also, as developers, we tend to make builds faster and to have less junk in final images. So usually we combine X, Y, Z into just one instruction, which is saved as one layer. So images are smaller, and clients of your images would pull less from network, and there would be less junk inside. For example, consider such instructions like you get archive from network, you unpack it as next step, next instruction. You do make install or pip install, and then as last step you just remove some junk, right? So this would be stored as 4 layers, and only one layer is good, and 3 of them are just unnecessary. So you don't want to keep them. That's why people combine everything into one instruction. And this gives problem that if you have any change in X or Y or Z instruction, you get full rebuild and really new image afterwards. Another problem with having the greatest software and the newest version in Docker images is that when you clone from GitHub, you always get a new and unique set of software. You cannot have something like 2 builds of Docker container which do git clone of some OpenStack project. They are never unique. You always have git history and other files. Even if you put all files to have creation time as Unix birth, for example, it won't help because you still have different content in some git things. And you cannot remove git because pip install needs to get some versioning information from it. Okay, some space workarounds for containerization. So what is done currently, at least by Kolla project and a few others, is that we do a very, very big base image. We install everything inside, like all RPMs, all the tools. And then as derived images, we install Nova, Cinder, Keystone, and so on. So kind of very small diffs afterwards. It's not the best solution so far. It's less secure because your final image has everything, even if it doesn't need this. And upgrades still are slower to build and to distribute. So this is something like, so we still have to innovate in this area. Isolation and security, this is another topic. Docker does, but unfortunately in real world application like OpenStack, we cannot use this at that degree what Docker actually provides, because real world containers, they want to access host services, host networking. They want to load kernel modules, access processes on hosts, and do other things. And there is even a term called super privileged containers. So it's kind of containers that can access anything on host. So in this case, Docker is kind of only a package tool. It's not really a tool for isolation. So this is an example of what services require what host capabilities. So you will see that almost everything needs everything, right? Data backends. Docker is very good as a data processor, so containers are really, they help us to manage complexity. Where do we store data? Data can be stored in several ways. Docker container itself, this is ephemeral storage, and if you remove your container, you lose your data, so this is not really a good one. Recently there was a concept introduced like a data-only container, so this kind of design pattern or design anti-pattern, whatever you like. It's kind of you start container, it dies immediately and lays in the system, and you start other containers that mount things from this dead container. Yes. So this was introduced not recently. It was introduced probably and skipped already. So nobody uses this nowadays. because during upgrade, if you do upgrade of all your containers, your data is gone because container is also gone. So, and volume is still not the best solution. It's, you can restart your container, upgrade your container, but it's not easy to grasp data or choose location or for different characteristics like database. And I consider host folder, which is a non-Docker way to store data, is still the best one and very flexible, persistent, and very easy to manage. And a few words about configuration. This is overwhelming, and Docker doesn't bring much to solve this problem, so you still need Ansible, Salt, Maca, whatever templating engines to abstract you from those zillions of options what in OpenStack exist. So to conclude, containers really is OpenStack deployment because they put OpenStack into manageable pieces. Containers are great as data processors, but they are not good as data storage still. So it's better to manage data with something else. Special care is needed for for container construction because this is kind of strategic decision how you would do your updates, upgrades, and save storage space. Orchestration and configuration tools also necessary for Docker containers. So still would need Ansible, Kubernetes, and maybe Puppet. And to conclude this, Docker alone is not silver bullet, so you need for silver bullet, you need a kind of great mix of different technologies, including containers and other things. So thanks a lot.